Hi.
Hi.
So please introduce yourself.
Hello, my name is Atul Sharma and I am working as a senior engineer in Synaptics. And this is our new algorithm for tuning the brightness uniformity for 2D LCD panel with local dimming functions. So Synaptics has developed SB7900 IC. So where we can using this local dimming feature, we are trying to mitigate the mura effect of the LCD panels for automotive display. This is the basic of local dimming, how the local dimming for 2D backlight panel is behaving. So if you can see here, if this is a white image, the surrounding image which is black, it appears to be gray because of all the LEDs are on. So if we turn on the local dimming, only the region where white circle is projected, that is on behind.
So do you improve the kind of like mini LED backlight system, or what do you do?
This is for the LCD 2D backlight system, and because the mura effect on the LCD panel is mostly visible on the border side, edge side, so we are trying to eliminate that by this algorithm. So in the conventional method, what happens is if we increase the brightness, where the mura is observed, so the surrounding LEDs are also, or the pixels is also brighten up because of increasing the value of this particular LED. So in this new method, what we are trying to do is we are trying to observe the surrounding LEDs also, and then we are trying to compensate accordingly. So the method is very uniform in our case. So for this, what we are doing is we are trying to characterize the single LED and check its behavior characteristics, how the brightness level is getting deformed or spreading throughout the LCD panel. And then using this method, we are trying to calculate the pixel zones which we are divided like the LEDs. For each pixel zones, there is LED behind it. So we are trying to measure how much the pixel zone is being affected by a single LED. And this is the values which we have calculated by Cauchy distribution function fitting. And these are the 4 LED patterns which we are using to calculate each LED value for the particular LCD panel. And by using these 4 patterns, the calculation time is very reduced. So this is the experimental setup where we are using CA2500 2D color analyzer by Konica Minolta to capture all the images. And this is how the images are being captured for all the patterns. And this is our overall mura algorithm where we are calculating the demura by using the directive filter which we have calculated here previously. And these are the results for demura for 100 nits display and 600 nit display and 1000 nits display.
So how good are these results?
So the results are very good. Like if you see the demura of for PSNR, which should be higher, the value is better the image quality. So if you see the Synaptics demura is much improved than the conventional demura method. And similarly, the non-uniformity of the overall display panel should be less. So the Synaptics demura method is quite significantly less, the uniformity is very good. And this is the 4 pattern method is a very faster method to correct the mura, and it can be used for number, even if the LED array number is increased, then also the timing is same for the calculation. So this is our advantage.
Is this implemented right now in the smartbridge or the systems that have the local dimming that Synaptics is putting in the market?
Yes, we have smartbridge SB7900, so which is having this feature with local dimming and mura connection. Yes.
So does that mean you do better local dimming than the other? Is the best local dimming in the market?
Yes.
Because of these algorithms, but because of these findings you have?
Yes. Because of the findings, we have compared it with various panels and found it to be much better.
Would it make sense to have even more zones, more LEDs on the backlight, to have perhaps even micro LED in the backlight? Is that better?
Yeah, like if we increase the number of LEDs, the power consumption increases. So we have to like mitigate whether you want better image quality, then of course the number of LEDs are higher, they are better. Like if you want to consume like power also, like mitigate the power, and then we have to reduce the number of LEDs so that our image quality is not compromised, but we can save on power and cost also.
It's not possible to have the same power consumption with more LEDs?
It's difficult, like because as the number of LEDs increases, it will draw more current, so the power will definitely increase.
All right, so it's a balance.
Yes.
And also with the number of LEDs you have, you need to figure out how to do it the best way.
Yes. Like if you change the technology, like if you go to micro LED, where the number of LEDs can be increased for the same power consumption, so we can achieve that thing. Yes.
How would you do that? Is it just each LED can be less bright, maybe?
Yes.
Does that make sense?
Yeah, like that. Then we have to check like how we are compromising on the image quality of the display.
Because if there's twice as many LEDs at half the brightness, that means the peak brightness goes down?
Yeah, yes, but like as you see, we are trying to maintain the brightness level for like 100 nits, 600 nits, and 1000 nits. So we are not compromising on the brightness level of the particular display.
All right. Is it fun to work on this?
Yes, definitely.